In this problem, we need to determine the moment of force F about point O as a Cartesian vector. We know that according to the vector formulation to calculate moment about point O equals to a position vector cross the force vector. And this position vector can be chosen anyway as long as it starts from point O and it ends on the line of action of this force. So the position vector in this problem, this is probably the one that makes the most sense, which is the ROA. So ROA is not difficult to determine. ROA can be determined by the coordinates of point A. Therefore, that's going to be negative 4I plus, along the y direction, positive 4j plus 2k in the unit of foot. So now we need to determine the force as a vector. We already have the force magnitude. It equals to 600 pounds. So we only need to determine the unit vector for this force. So in this case, the unit vector cannot be determined from the position vector. It cannot be determined from the three coordinate direction angles, alpha, beta, gamma. However, we are given some geometric information. So we know that if we resolve this force along this direction, this component right here will be our 600 times sine 60 degree. That will be our z component, because it is the component of a force F along the z direction. And this component right here is not Fx nor Fy. Let's call it F prime. However, this F prime component, and we can know what it is, it equals to 600 times cosine 60 degree. It is the resultant force of our Fx and Fy. So this is our Fy, and along this direction, this is our Fx. Therefore, we can further resolve F prime into the x and y components, and from there we can see that Fx equals to, in magnitude, F prime times sine 30 degree. But because it points to the negative x direction, so that's negative F prime times sine 30 degree, which equals to negative 600 times cosine 60 degree times sine 30 degree. And similarly, Fy equals to F prime times cosine 30 degree. It is positive. So 600 times cosine 60 degree. Again, this is F prime times another cosine 30 degree. So from here, we can determine the x, y, and z components of our force F. Therefore, we can resolve it into a Cartesian force vectors. That will be negative 150, that's Fx I, plus 260j, that's Fy, plus 520k in the unit of pound. So now we have both the position vector from point O to the force, and we already have the force as a Cartesian vector. Now we can determine our moment using the vector formulation, ROA cross F. We're going to set up a matrix, so IJK. And then ROA, the components are negative 4, positive 4, and positive 2. The three components of a force vector, negative 150, 260, and then 520. And then we can do the calculation. For the I component, we take this multiplied by, for the I component, we take this multiplied by this, minus this multiplied by this. Therefore, we have 4 times 520 minus 2 times 260 I, and then we do a similar thing for j, except that we start with a negative sign. Negative 4, this multiplied by this, times 520 minus 2 times negative 150 j. And lastly, we switch back to positive sign. For k, negative 4 times 260 minus 4 times negative 150 k. And then we can evaluate that, and that's 1560i plus 1780j, and then 440k. This is in the unit of pound-foot. You can keep it like that, or if you want to convert that into kip foot, that's fine too.